Welcome to AP Calculus. Here is your 4.4 homework, first homework video. The first section actually is 2 through 26 long before we change themes, but because there's that length, and I just want to make it easy for people to isolate their problem. If you have a problem on number 8, that's why you're here, because this is going to be labeled 2 through 14, but you're already here, so you already know that. So 4.4, hey, 4.4, no problem. We just got some new rules to remember, and to be honest, I think they're easier than the trig rules. None easier than this, which is just a snippet, literally a snippet from your handout that you have, which says the derivative of e to the u, and this really should say e to the u's derivative is e to the u du dx. And when we see u, we should be thinking that's a function of x. So if it was just e to the x, the derivative with respect to x is e to the x, dx dx, but dx on dx is 1, so it's just e to the x. E to the x's derivative is e to the x. So the slope of e to the x at 7 is just e to the 7th. Kind of an interesting one. So this du dx just represents the derivative of the inside function, u being a function. So this one, dy dx, I'm going to write dy dx, not y prime, because they ask for this. Now, you may have started to already get in the habit of, if you have an inside derivative to find, and we do, this 2x, we have an inside function, so the inside derivative, you may want to leave a little space. So I'm going to go e to the 2x. That is the e to the leave the baby alone. E to the leave the baby alone right here. And then take the derivative of the baby function. Derivative of the baby function is 2. And that's it. If only it was that easy. All of the time. So number 4. Y equals e to the negative 5x. Well, right now it is that easy all the time, except I guess we're working with a negative number. But dy dx is the derivative of e to the, leave the baby alone. Then when the baby's born, times, treat the baby. So either times negative 5 or negative 5e to the negative 5x. Number 6, I'm sure it's going to get harder soon. Let's see, looks like we've got another e here, so this is y equals e to the negative x on 4. You may want to, when you see this, visualize it or even rewrite it as negative 1/4 x, and now it looks a lot like this previous problem. So dy dx e to the derivative becomes e to the, I'm going to write it as negative x on 4, but times the inside derivative, times negative 1/4. And that's where perhaps we look in the back of the book, and maybe the back of the book writes this as negative e to the negative x on 4 over 4. Or maybe they write it as negative 1 on, wow, that my x looks an awful lot like a pi. Maybe they write it as negative 1 on 4 e to the x on 4. So just always constantly in the habit of just trying to work your algebra to match the back of the book. Okay, number 8. Can it stay this easy? Number 8. I knew that the good times would have to end. Number 8, we've got x squared, or y equals, I should put that in there. Y equals, squeeze this guy, x squared e to the x minus x e to the x. And what we have here is a product rule. And what we have here is a product rule. And I'm going to make a habit out of always writing parentheses around my product rule. Is it necessary? Not all the time. We'll come right back to that. Product rule. I want the first x squared times the derivative of the second. Derivative of e to the x is e to the x plus the derivative of the first, 2x, times the just plain second, e to the x. Did I need those parentheses? Nope. minus product rule. The first x times derivative of the second, e to the x, plus the derivative of first, 1, times the plain old e to the x. Did I need those parentheses? You bet I did, or else I would have had to remember to distribute that negative. So let's see what good happens here. I've got an x squared e to the x. I don't have any like terms for that. I've got a 2x e to the x. So this is like 2 apples minus 1 apple. I end up with 1 apple. So plus x e to the x. And then I get, careful here, a minus e to the x. You don't distribute that negative for whatever reason. You didn't put the parentheses, or you did and you forget to distribute it. That's going to be a harsh hit. That is not a mistake that calculus students make after taking algebra for the last 4 years minimum. Since 8th grade you've been working with algebra. Find a new mistake. I've had it up to here with the mistake of not distributing negatives. So that's going to be a big hit on that. Minimum, if this was a 5-point problem, that's a minimum 2-point hit. Minimum. Okay, number 10. Try to get happier here. Number 10, just the thought of not distributing negatives just about makes my blood boil. Here we go. Y equals e to the x squared. Well, I love e to this. dy dx is e to the. All that's left is just to take the derivative of the inside function. And the derivative of the inside function is the derivative of x squared, and the derivative of x squared is 2x. So it got easy in a hurry again. Okay, let's move on. So far we're just specializing in one new rule, e to the x's. Here is next problem, number 12. Number 12, we have y equals 9 to the negative x. I wish it was e to the negative x, but it's not. So, another snippet. If it's not e to the, if it's a, some value a to the, we still treat it as a to the. But since it's not e to the, we compensate with e to the's inverse. We take ln of a, or our base. Notice ln of e is 1. So if a was e, we'd be multiplying by ln of e, we'd be multiplying by 1. Wouldn't even need it. So we multiply ln a, or in this case, dy dx. It wants to stay the same, but it's not base e. So we base e it by using inverse e to the. We change the base, or we use the base in there. And now we still have to treat the baby. So I've got 9 to the negative x, ln 9, but I still have to, oh, okay, this negative x, I need the derivative of that. So it is negative 9 to the negative x, ln 9. How might this be represented? This might be, we'll check it in a second here, maybe I'm going to leave negative ln 9 up here and move 9 to the positive x into the denominator. Just a guess. Nope, my book answered it like that one. But be prepared. You're going to get, maybe you already are sick of me saying it, but be prepared to work the algebra to match answers. Okay, last one for this video. I know this is a quick one, but again, the more of these I do, the more you can isolate the problem you want to look for. If you're using this thing honestly, you're not really probably looking for a whole list of problems anyway. You're looking for either an example or one specific problem. So, number 14, y equals 3 to the cotangent of x. Somewhere down the line, I'm going to be taking the derivative of cotangent. All right, but this is still falls under this rule. So dy dx equals 3 to the cotangent of x. It's not e to the, so I compensate with e's inverse, ln of the bad base 3. I wish it was e. But I still need to take cotangent of x's derivative. And cotangent of x's derivative is negative cosecant squared x. How you doing learning those trig derivatives? Boy, you don't know our trig derivatives and you don't learn these ones we're working on now, it's going to be a rough test for you. So since this is negative, I could put the negative secant squared first. I'm definitely going to put the negative first. Maybe I'll just leave everything else in a row here. 3 to the cotangent x ln 3. There'll be some argument maybe ln 3 should go out in front because that's just a constant, times cotangent x's derivative is negative cosecant squared x, and the baby is just x. So let's take a look. I'm curious. I'm going to look in the book, see if that ln3 is first. Just a possibility there. Nope, they have it exactly in the order I have it here. So anyway, I'd kind of like negative ln3 then times, but no problem. Okay, so that is it. I'm going to wrap that one up right there. Just a quick little 11-minute video, and I'll be back with some more soon.